Hey guys, welcome back to another episode of Tech Tutorials. In today's video we'll be talking about Git. So most of you watching will probably agree with me when I say that we've all experienced problems when developing applications, especially when working in a team. The most common problem of course being that it's almost impossible for everyone in the team to share and collaborate the same lines of code at the same point in time. Not to mention also that it's incredibly slow and manually intensive to continuously check for changes, and the confusion and communication between the team is just too difficult to keep track of. Here, let me provide you a more clear example. So, meet Jeffrey and meet Rachel. So Jeffrey and Rachel here are designing a child application for a university project. The problem here being that Jeffrey is hardly attending class because he'd rather be out skateboarding, hanging out with his friends, whereas Rachel is stuck with too much on her plate balancing between uni, work and taking care of her cats. Neither Rachel nor Jeffrey have any free time in their calendars to meet up and do their project, so they attempt to finish the project from home. They keep running into problems though because they keep working on the same lines of code in the application, which is causing them both confusion as they keep deleting one another's work. Jeff then remembers a while back his tutor explained to him about something called Git and how it would be a solution to his and Rachel's problems. So what is Git and why is it the solution? Well, Git is an example of a DVCS, a distributed version control system, rather than one single place for a full version history of software, as is the common in once popular version control systems like CVS or Subversion, also known as SVN. In Git, every developer's working copy of the code is a repository that can contain the full history of all changes. Now, if you don't know what version control systems are, well, especially a bunch of software tools that help manage changes to code over time. Version control software tools keeps track of every modification to the code in a database, meaning you can go back to the code to the state it was in modification, sort of like an undo button. Think about all those times where you've worked on a project and saved your code after making good progress, but it contained an unforeseen error that eventually caused a bug in your application. Git version controls allows you to go back to past versions of your code and quickly locate where things went wrong. And for the purpose of this tutorial, we'll be using GitHub as a Git repository. GitHub provides a web-based graphical interface. It provides access control and several collaboration features such as wikis and basic task management tools for every project. So in conjunction with GitHub, we'll be also using SourceTree. SourceTree, made by tech giants Atlassian, is a free-to-use application allowing users to interact with their Git repository where the code is stored. It is a graphical user interface application, and from SourceTree the user then can change code and upload it directly to the Git repository. So before you guys want to listen into the tutorial, you guys can head over onto this website and download SourceTree. It works both for Mac and Windows. And you guys will also need to sign up for an account using Git to use GitHub, and you guys can do so over here. So once again, I have Rachel and Jeff to assist me with the tutorial. So now let's see how they're using GitHub and SourceTree for their project.
Hi, I'm Rachel and I'll be teaching you the basics of Git that I have learnt in order to use it for mine and Jeff's assignment. I'll start off by teaching you how to create a new repository. So a Git repository is where Git stores the data for the files you're going to be saving. In order to do anything in Git, you need to first have a repository. So this is the first page that will open up when you first open SourceTree. I'll just click on the new repository button now. There are two main ways of obtaining a Git repository, as you can see in this drop-down list. One way is to simply initialize a new one from an existing directory on your computer, And the second is to clone one from a public Git repository, which is what you would do if you wanted a copy of work that someone else has done or wanted to work with someone on a project on the same files, which is what we will be doing in this tutorial. I'll be cloning a repository that Jeff has already created for our assignment. So I'm just going to copy in the URL of Jeff's remote repository and save the clone repository in my documents folder, in a folder called Git Good. I'll name the repository Git Tutorial and click clone when I'm finished with that. So now that clone has been created, a new window pops up where all the Git magic happens. So we can see that in the clone repository, Jeff has already uploaded a file, and now we'll open that up in NetBeans and have a better look at it. So now you can see that I have a task to do, which is concact array, the concact array method. I'll just quickly copy in my solution that I've already pre-written and save that. And now I'll just check back onto source tree, and you can see that I have an uncommitted change. Next up, we'll be making a new branch. So a branch is a parallel version of a repository. It is contained within the repository but does not affect the master branch, where you should only push code onto that you are 100% confident with. Branches allow you to work freely without disrupting the live version. We'll create a branch by clicking on the branch icon up here, and since we are working on the concact array method, we'll name the branch concact. So the next step after creating our branch will be staging and committing the changes that we have just made to the assignment file. We want to stage and commit to the concat branch we have just created. So staging a file just means that you are preparing it for a commit, and to stage a file you just go into the branch that you want to commit the changes into. And for us this will be the concat branch. Then just select the unstaged files that you want to stage. We only have one file to be staged, so we'll just click here. And as you can see, this brings the palindrome checker Java file into the staged sections ready to be committed. Committing a file is like when you save a file, except with Git. Every time you save it, it will create a unique ID, which is also known as a hash, that allows you to keep record of what changes were made, when, and by who. You are also able to stage and commit more than one file at a time. To commit, we just click on the commit icon in the top left of source tree over here, and when you make a commit you should insert a commit message of a brief description of what changes were made. It is good practice to write comments in present tense. So now you can see that we have successfully committed our changes into our local concat branch, and you can also see that Jeff has recently pushed and merged his changes into the master branch in the purple just below. Let's have a look at what he has done. Good job, Jeff. Earlier, the branch that I created was only saved onto my local repository, so I want to let Jeff see that I've completed my concat array method, so I'll have to push the concat branch into the remote repository of our assignment. To do this, we click on the push icon up here and select the concat branch and click OK. So now we just want to double check that my concat branch was actually pushed into the remote repository properly. And as you can see, it has worked like a charm. I just want to take a moment to explain another useful Git function, pull. Pulling is used to pull in new changes made by others in the remote repository and merge them into your local repository to keep your work up to date. Now I'm just going to be demonstrating that the master branch contains the methods that Jeff has completed, and I have yet to add my concat array method onto the master branch myself. So to do this, I'll need to merge. Merging is when you take the changes from one branch in the same repository or from a fork, and then apply them into another. To do this in source tree, we start in the branch that we want to apply, which is the concat branch in our case, and then we click on the merged icon here, and then we select the branch we want to merge into, which for this tutorial will be the master branch, and then we click OK. We will then again need to push these changes into the remote repository so that Jeff has access to the changes that I have just made. We'll do this by pushing the local concat branch that I have onto the remote master branch in the GitHub repository. And then click OK. And yeah, that's done, I think. Okay, so we'll check this by going onto GitHub and reloading the master branch. And as you can see, it is all there, and that's it for the basics. Now we'll move on to Jeff to show you one way why Git is so useful for students like us.
In this section, we will show a merge conflict issue that arises often in collaboration projects. The point of this section is to explain what a merge conflict is and how to deal with it. Here we have an initial commit that consists of a few methods. We want to add the multiply method onto the project. So let's add that in quickly. And here it is. So this is our commit, or our changes in our file. So we'll refresh it in source tree, and here we have the committed changes. And on the right side we can see the new added multiply method. So let's make a new branch and commit our new method onto the part 1 branch. So here we can see, here we can push it onto our actual Git repository, and just always write a comment when you commit something, so when you look back you can see what you've changed. So we completed the multiply method in this case. Alright, so here we are. So let's go back to the master branch and make some changes. Let's say, for example, someone on the master branch didn't know that someone else has made changes into the part 1 branch. So let's write another method into the master branch. I'll just open up the file again so we know that the Java file is originated from the master branch. So let's copy the print name method, and here we are. So we've written the print name method, so let's commit this change and try to merge the two parts. So here we are, let's write a comment again, completed print name. Okay, so here we are. So we have a completed part 1 method and also a completed master method. Now what we want to do is try and merge the two branches together. So let's do that really quickly. Okay, so here we can see a merge conflict message. When merging, Git usually looks at the difference between the two commits, or between the base commit and the other branch's latest commit, and automatically merge the differences. However, in our case, there is a conflict between the changes in the master branch and a conflict between the one in our branch. It just doesn't add up. That's why we have to manually change it, and there's no way to avoid this when there's a merge conflict. Between the arrow with head and the equal sign shows the changes in the current branch. In our case, this is print name. Below shows the commit changes in the branch. Now, say we want both methods, so we can go in our file and just remove all the arrows and merge the two commits. So let's do this really quickly. So we remove the head, remove the equal signs, and also part 1. And we'll just include the bracket for print name. And let's save the file. And here we can see the uncommitted changes, so let's just quickly commit that. And here we should write a message for our commit. And so let's just write something that is more understandable to the reader instead of merge branch 1 part 1. So here we go. let's just say merge print name and method because we wanted both in the file. Print name and multiply. And so we'll just commit that. And here we are. So we've successfully merged both branches, even with the conflict error. And here is the final product, or the final code.
Thanks both Rachel and Jeff for their help with using GitHub and SourceTree. Hope you guys have been able to learn a lot from this video about using Git, especially how to push, pull, branch, and merge lines of code. But hope you guys also learned what to do when you guys come across merge conflicts on SourceTree. Thanks for watching. I hope you guys enjoy this style tutorial video. Remember, if you guys wish to see more tutorials, please give us a thumbs up and subscribe to our channel. See ya.